Some of the things we learned in that initial high level discussion with the domain expert included the fact that patients and clients are not the same thing to a veterinarian.
Yeah, that's pretty obvious in hindsight. But in most other medical professions, it is the patients who make appointments and pay the bills. It's good we were able to get on the same page with the customer on that early on in the process.
I think it helped Dr. Smith put some of the processes she uses into explicit terms that we could program against also. A lot of times, just describing the process to someone who's unfamiliar with it can really help improve the understanding of it. It's like that idea that when you have to teach something to someone else, it makes you learn it a lot better. Listen to what Dr. Smith had to say at the end of our conversation about this.
Yeah, I never really thought about the details of how we do some of these things since it's just something we do and we don't really think about it. Being more explicit about what the rules are that determine how we do our scheduling could help us avoid some of the occasional scheduling problems we've had. This is going to be great.
We also need to remember not to use too much programmer jargon, especially when there are programming terms that might have a different meaning in the customer's domain.
I agree. It's a little early for us to be worrying about how things might end up looking in the code anyway. At this stage, the main focus is on understanding the domain. We'll get to building the software soon enough, but first we want to make sure we know what problem it's going to be solving. One of the most important things we can do as we explore the problem with the domain expert is to try and make their implicit knowledge about the process they use now explicit. Once we're able to capture the process and its rules and exceptions with some detail, we can start to work on modeling a solution using this information.
Building software is hard. One of my favorite sayings is, as software developers, we fail in two ways. We build the thing wrong, or we build the wrong thing. By making sure we understand what the customer needs, and of course working closely with the customer throughout the development process, we can dramatically reduce the likelihood of the second kind of failure, which is much harder to fix typically.
Hey, Steve, I like the way you quote yourself here, but it really is a great quote. After talking to Dr. Smith about how appointments work, we've identified a few high-level elements of our model. The central concept in this application seems to be the appointment itself. Typically, an appointment is scheduled by a client for a patient. Booking an appointment often requires an exam room and a doctor, but may involve other resources. Appointments might be for office visits or vaccinations. Or they might be surgeries, which are a separate kind of thing entirely with their own rules, which involve different kinds of procedures. Surgeries require different resources, too, like operating rooms and recovery rooms.
That's a pretty good high-level view of the model we have so far for the appointment management part of our application. I think it's worth noting that some of the concerns of this application are going to also play a part in other subdomains. For instance, I'm pretty sure we're also going to be working with clients and patients in a lot of the different parts of this application.
Yeah, I think it's time we introduce the idea of bounded contexts.
As you develop your model, remember to identify its bounded context. That is, where is this model valid? If you don't put boundaries around your model, eventually pieces of it will be used where they don't fit. Concepts that make sense in one part of the application may not make sense in another, even if they have the same name, and sometimes even if they literally refer to the same thing.
For example, as we built out the appointment scheduling portion of this system, we needed to know some very basic information about clients. But in the context of appointment scheduling, these are very simple concepts with little behavior beyond their names. However, in the billing context, we'll want to include contact and payment information for clients. But that's information we don't care about back in the appointment scheduling context. If we try to reuse the same exact client model in multiple places, it's likely to cause inconsistent behavior in our system.
That's right. For instance, we might decide to include some form of validation on clients to ensure we have enough information to bill them. If we're not careful, that validation might inadvertently prevent us from being able to use clients to schedule appointments, which certainly isn't the desired behavior. Maybe the billing system requires that clients have a valid credit card in order to save changes for them. But it wouldn't make sense for a lack of a credit card to prevent us from saving an appointment for a client in the appointment scheduling system. In this example, we have two contexts, but the boundaries between them are blurred and overlapping. Eric Evans notes that models are only valid within specific contexts. Therefore, it's best to explicitly define the context within which a model applies. We should be able to avoid compromising the model within this context, keeping it strictly consistent within these bounds, and avoiding distractions or confusion from outside issues.
Once we explicitly define our bounded contexts, we can easily see whether or not we have elements of our model that are trying to span multiple contexts. In this example, we'd want to keep a simple view of a client in the appointment scheduling app and a richer version of the client with contact and billing information in the billing context. We would define these two views of a client in two separate classes, and they will most likely live in separate applications. In fact, Evans recommends that bounded contexts maintain their separation by giving each context its own team, codebase, and database schema.
While this is ideal, in many real-world apps, we need to work on systems where this level of separation is not present, usually due to resource constraints or for political reasons within the organization. Remember, though, if you have multiple contexts, you'll want to keep them bounded, and one way to maintain this separation is to keep their data, code, and team members distinct from one another. Although, in real world, I've never seen something with that level of separation.
Yeah, but I think even if it's not possible to literally do that with your company and your team, just having that concept in mind really helps in your brain have that idea of separation.
I agree. I know that just thinking about the fact that these things ought to be separated and trying to figure out a way to do it means that even if you can't get to the ultimate level where everything is completely separate, you can still introduce separations through things like namespaces, separate folders, separate projects, anything you can do to make it clear that these are different contexts that shouldn't be sharing too much information.
I think that's also a really important point about this course in general and DDD in general. For me, it's really hard to think of all of these things we're learning as hard and fast rules, like you have to do it this way or you're not doing it right. I like to see all of this as really good guidance. So, it helps me keep my eye on the prize. And when there's places where I can't truly achieve exactly what DDD kind of directs me to do, I'm using my own experience, my own intelligence to make decisions about how to do things. And I'm letting DDD guide me in a lot of scenarios.
Sure. And some of these ideals, I think of like 100% test coverage. It's almost impossible in most real-world applications to achieve 100% test coverage. But just because that ideal is not something you can ever achieve doesn't mean that you shouldn't strive for more test coverage.
Yeah. Totally agree with that.
When learning about DDD, most of us have a hard time understanding how subdomains and bounded contexts are different. We asked Eric Evans about this and got some great insight. He explained that a subdomain is a view on the problem space, how you've chosen to break down the business or domain activity, whereas a bounded context represents the solution space, how the software and the development of that software has been organized. Quite often, these will match up perfectly, but not always.
Eric helped us understand this further with the example of a room that you want to cover with carpeting. The room is the problem space, so it's like a subdomain. You could install a wall-to-wall carpet that matches the shape of the room perfectly. This would be like when the subdomain and the bounded context encompass the same thing. But other times, you might just use some area rugs to cover the floor. And the area rugs solve the problem. They cover the part of the floor where you walk, and you don't have to worry about cold feet in the winter. And that's a scenario where the area rugs are like bounded contexts that don't match the subdomain. But they solve the problem, even though they're not an exact match to the shape of the room. If your organization has multiple bounded contexts, and ideally these are separated, there can be confusion when the different teams are talking to one another. Again, DDD focuses at least as much on effective communication as it does on anything specifically related to the code we produce. Evans recommends using context maps to visualize and demonstrate to all teams where the boundaries between their contexts lie.
Think about a complex topographical map. It will frequently include a legend, like the one shown here, in order to explain what each of the lines and symbols on the map mean. However, this legend is only valid within the context of the map with which it appears. Trying to use this legend on another map would be confusing at best.
A good first step for an existing application is to create a map that shows how things are. Remember that the names of your contexts are also important, as you'll refer to them frequently when discussing different parts of the application. It may be that things are not as separate as they should be, and that's worth noting. If you have separate teams responsible for different contexts that share resources, it's important that each team understands which aspects of the application they can change on their own, and which are shared dependencies they'll need to coordinate with other teams to avoid breaking things. If we look at these two sets of concepts, we can see some obvious overlap. For one thing, client appears in both contexts, but we know that for appointment scheduling, we really only care about the client's name, whereas in the billing system, they'll want additional information like address and payment details. However, although the details involved vary, we know that Mr. Jones, the client on the left, is the same actual person as Mr. Jones, the client on the right. However, we also have a concept of notifications on both sides, and in this case, they're referring to different things. On the left, we're talking about sending a notification when an appointment is booked, as a reminder, and on the right, we're talking about notifying the client that their payment was received, or perhaps that it's past due.
Especially in smaller organizations, it's common to have one team responsible for several contexts of the same overall application. In such cases, it's also common for the team to use a single codebase for the bounded context that they're working with, and store it in a single repository, such as GitHub. Usually, there will also be a shared database. As we've already noted, this is not ideal, since it makes it much more difficult to maintain the boundaries between the separate contexts.
Part of creating a context map involves explicitly identifying its boundaries. If we try to draw the boundaries around these two bounded contexts, we can see there are now several resources that belong to each bounded context. This isn't ideal if the two contexts really are meant to be kept separate.
In the ideal case, for a large, complex system, we would have bounded contexts like these, with their own teams, codebases, and database. For instance, on the left we have an appointment scheduler application. It's being worked on by Team Awesome, and they're storing all of their code in their own repository called Vet Appointment Sched. And of course, this application has its own database. This team is free to change anything they want with their model or any other part of their system without worrying about breaking anything outside the boundaries for the team on the right, which is working on a billing system, and their team has decided to call themselves Team Ultimate, store their code in a repository called vet-billing, and of course, using their own database. By having this separation, this can greatly increase team velocity and reduce integration bugs.
Of course, you're probably wondering how the two systems will interoperate. There are a number of patterns that can be applied to enable this kind of integration. We won't be covering all of them in this course, but one question that frequently comes up is how to share cross-cutting concerns, like logging and shared abstractions such as people names that are used by multiple bounded contexts. For this scenario, a common approach is to designate these shared concepts or resources as what we call a shared kernel. Team Awesome and Team Ultimate agree to share the subset of the domain model. Since they're sharing it, they also agree not to change it without coordinating with the other team first. Frequently, the shared kernel will either be a part of the customer's core domain or some set of generic subdomains, or even both, though it can be any part of the model that both teams require. Using a shared kernel is a trade-off between code reuse and consistency, and the overhead involved in integrating changes to the shared kernel across multiple teams and bounded contexts. It works best when the shared model is relatively stable.